For your presentation. Okay, our next presentation is about design and analysis of topological phonolic crystals with cavity, and the presenter is Jia Ye from Tsinghua University of Medical Technology, Taiwan. Please. Figure out 12 minutes present and 30 minutes for Q&A sessions. Hope I pronounced your name and your university thoroughly. You can introduce yourself.
Okay, thank you, Chair. Thank you, everyone. I come from Taiwan, and I'm working in Tsinghua University of Medical Technology. So today I present some research about phonolic crystal with cavity. Right? So this one. At first, this abstract. The topological phonolic crystal is combined with different material. So we can this topic I work design two different type of phonolic crystal. And how to design? I use some theory about topological. And why I using topological? Because for generally, we using phonolic crystal to maybe we using wave propagation in this crystal. Maybe we will meet some problem. The first problem is your wave propagation maybe absorb, maybe vanish, maybe reflection. But using a topological theory, I can reduce the reflection and enhance the wave propagation effect. So there is some reference. So the topological theory is maybe in these few years, some research using this theory to design some new device. But maybe initially the phonolic crystal, maybe using about my above research, I using this device, maybe using in energy harvest, like the first presentation. But the cavity and maybe the frequency is very high. So if you want to use it like the first presentation, we using the general force. Maybe you can create very high voltage, but the energy is very small. So I changed my research to measure in wave propagation. And then another one, the topological is I using this device to measure in topological. So we can see there's some formulation, and the formulation I use is the whole quantum value theory. So this one I using the final element the method to analyze my model. So I using this triangle 6-node element, and each element has 6 freedom. So and we can see this one we can using the software. I using the software is Comsomatophis to show the wave propagation effect. So this one you can see I want to show the device is good and better than others. So I using this quality factor. And the quality factor we can see in the cavity. We will find this very high or higher pressure when we using this. When we using this to design the cavity, and we can have a very higher pressure. And the high pressure we can focus. Maybe the wave propagation, we can focus the pressure and focus the signal, and maybe we can use it to maybe some medical design, medical technology. Okay, so this one I will show everyone. This is my model. The first model, the A is the topological, the type A. And another one you can see, we rotate the angle about 45 degrees. You can see is the plus 45. And another one is minus 45 degrees. And the model is the same, but I just rotate the different direction. But if you return the different direction, you can easily to control, and you just replace one of them, one of the conical crystal. You can get very better crystal in this technology. So you can see this one. For this one, this is my model, and the original whole model is designed from the type A, and the focus I designed a cavity. The cavity you can see I insert the wave propagation from right side, from left side to right side, and you can see we can find there's a very maybe 15 the resonator frequency. But resonator frequency you can find maybe the first one to 15 is different. But I find this if I try different, you can see the cavity, the pressure is different. So I choose from n equal to 1, 2, 3, and 4. Then this one I choose the n equal to 3. One can find this is a very high pressure, and the frequency is 5896. So this one is I using the frequency I select, and I will choosing different the n equal to 2, 3, and 4, and the quality factor you can see. If I choosing n equal to 2, the quality factor is just about 2000. But I choosing n equal to 4, the quality frequency is 29,000. But if I choosing n equal to 3, the quality factor is very higher. That means the wave propagation I through this cavity, you can get a very higher pressure. The higher pressure maybe you can use it to receive some signal, and the signal maybe you can use it maybe in medical or use it in some energy harvesting. It's a very good effect. So let's mean if I use it topological, I can get a very good results. Okay, so I give some conclusion. The first one, I using this numerical results, and I using software to verify my theory. It shows very better quality factor and higher acoustical pressure in this model. The second one is the different size, and when I change the resonator frequency, and the quality factor also can be changed. That means I can design some controllable device. Using maybe this some parameter. Okay. Another one is parameters. I using quality factor and acoustical pressure, and all can utilize to design some novel device about the acoustical device. Okay. The final one is I want to maybe provide some basic guideline to using the topological theory to design some acoustical device, because the photonic crystal or photonic crystal all a very good topic to maybe check the wave propagation or signal propagation. Okay, so that's all. Thank you everyone.
Okay, thank you so much for your presentation. Okay, any questions? Yeah, I have a question. Can you show me your resonance frequency and why you choose this frequency? This is the incidence frequency. Yeah, in the slides before this. Yeah, okay. Here.
This one?
The next slide.
This one?
Here, resonance frequency is 5896. You choose it by your own in your model. You added it as an incidence frequency.
Yes, I use it numerical results. I analyze and I check which n is the better. So I just try everyone. Maybe to n and 1.
Yeah, you try different resonance frequency and you choose this one.
Yes, I choose this one. Yes.
And based on this, your quality factor is improved in n equals to 3. Yeah.
Yes. So maybe if for my global research, the quality factor maybe just the maximum maybe just 2,000 or 5,000. But I using topologic, the quality factor maybe over this one or 53,000. The value is very good. So I think this and the other maybe some preference I found. They also discuss the quality factor because it's very good. So maybe I say you can use it maybe the focus, use signal focus effect. You can design by this cell.
Okay, thank you
Okay,
so
thank you.
much for your answer.